Hi, and welcome to Mike Likes Robots, where we share knowledge to accelerate robotics. And today we're back to doing Advent of Code. Today is day 7. So let's take a look at the puzzle. Today's is called Bridge Repair, so I'm going to read through this and cut to when I'm done so I can explain it. Okay, so this is another easier to understand puzzle. I think there's a couple of ways that it could go for part 2, but for part 1 at least, we have a test value on the left and then a series of values on the right that we need to either add or multiply together in order to make the test value. We then need to sum the values that can be created from the values on the right. So some of them can't be constructed and some of them can. Now, initially my thought is that I should test adding and multiplying all of them together. I can't think of a smarter way to do it. So I'm hoping that I can brute force it and then I'll try it on the full input size and it won't be too overwhelmingly large that that's not feasible, which does start to happen around these days in Advent of Code. Things start to get a bit more tricky and your initial thought of how to complete it ends up not working. Not working for the full size input. So let's start by creating a project for day 7 and we'll start parsing this text. Now the past few days I've spent a fair amount of time parsing the text of the puzzle and explaining it as I go. I'm going to try and skim over that a little bit more going forwards, just to speed that up a bit because I think it's less interesting than the actual puzzle solution. So let's start by creating the test text. And I'll create a structure for the puzzles. Which will be a calibration set. It will contain a hash map. Don't see why not. The hash map will map I32 to a vector of I32s. Okay, this is just the standard setup for our from string method. So from here, I should be able to derive debug on this set and read it in. Okay. Okay, with that, I'm printing out the empty version of the calibration set, so now I just need to work out the actual parsing code. So we're going to take a line in puzzle.lines. For each one, we will each one will take the key as the line.split by colon dot first. Ooh. So first I'm reading out the key and I'm checking, I'm taking the nth index, which will give me the first value, the value before the colon. And if there is no value, then the key is missing. Although this will never fail. I think if I have any string here, it will give me a 0th value. So this is kind of a pointless check, but I think it makes it clear what I'm trying to do. I can do the same thing for line.split by colon dot nth 1. This should be the values. And then I can OK or the calibration set error values missing, question mark. I'm actually going to rename this to values raw, and then my values will become values raw dot map dot iter. No, I need to split by space, and then I can map any of those to x.parse, and then I can collect that. Now it won't know what type of vector to collect it into, and that's fine. I think I'll need to filter map this. .ok, and then it needs to know the type annotations. There it is. So at this point, I can insert a new calibrations. So I can let mute calibrations equals hashmap new, and then I can insert calibrations dot insert the key against the values. Then, when I return calibrations, all of the type information will propagate back. Except that I32 needs to be parse.ok, question mark. So I use it directly on the parse. No? Okay, I'm a little confused at this. We have a string. We're trying to parse it. It returns a result. Result is what I can use a question mark to unwrap. But it doesn't like it because it needs to be an error type we understand. Okay, so we're actually going to map the error to a calibration set error key missing. It doesn't matter what we're passed in. We want to return a key missing error. Then we can parse that. Okay, so that is somewhat interesting. The question mark only works if you're returning the same error type as you're expecting from the function. So because parse returns a parseInt error, I can't use a question mark on it. I have to convert the error to a different error type. There we go, that works better. And instead of having values raw, I can just continue this chain and then dot split In fact, I can just remove this line. Which turns it into values. Okay. No method found for that. Needed the question mark, and now it is happy again. So that's our parsing logic. So now if I run this, it should give me several options. Let's take the first one. Okay, 190 is made up of 10 and 19 in some way. Correct. So we've got that. Everything is being read in correctly. Now we need to actually write the solution for it. So for this, I want to go ahead and start writing the test module again. I could have written a parse function correctly test, but I didn't feel the need to. It seemed simple enough to parse in that I didn't need to write a test. Of course, in professional software development, you'd write it anyway, but this is advent of code. This is fun. So we're going to test a valid line. In fact, I'll start with test simple valid line. Our calibs will be let mute calibs equals hashmap new calibs dot insert, and it'll be 190 versus a vector of 10 and 19, and then return calibs. Let calibs equals calibration set. I'm pretty sure you can just shadow variables like this. I'm not sure that I would recommend it, but it's doing what I want. So, but for now, this is fine. It would be confusing if I went back to it, but this is fine. Okay, so now I want to show that there is one valid line of calibration. So I'm going to assert that part A for this, which doesn't yet exist, is 1. So there we go. I'm now going to implement calibration sets. I'm going to create a function part A, takes a reference to self, and returns usize. I'm going to set it off as 0, run my test to make sure it fails. It fails, good. And then I can start implementing the solution. So I'm going to iterate over all of my calibrations. Iter, I believe, gives me a tuple of key and value, so I can filter. And for a key and vals, I can check if a combination is possible. So I'm going to give a combination possible, which is going to take key of I32 and vals of some iterable of I32 as well. It will give me a bool. I'm thinking with part 2, we'll have to count how many valid combinations there are. So I will probably rewrite this later to give a count instead, and then I'll check if it's equal to 1. But for now, this is fine. So I'm going to check that the combination is possible. This is a static method now. So combination possible between key and vals. And then I can return the count. And I think this isn't happy because I didn't close the tuple before the pipe. And this isn't happy because I need to take a reference to key. That's better. Okay, so you can either dereference in the function call, or you can take a reference in the closure arguments. Either way is fine. It just depends on personal preference, I think. I don't know if there's an actual reason to prefer one over the other. If you do know of one, please put it in the comments. I'd love to learn it. Otherwise, we're now down to this combination possible. So this is the actual meat of the puzzle. Is it possible to make the test value from the combination of values that we've got? Now, our possible operations are add and multiply. So we're going to try every possible combination of that. So I need to figure out how to encode that. I'm going to just write false to keep the compiler happy. Now I'm sure I could write this manually, but it's just occurred to me that there might be quite a neat way to write this, which is to use functools, which is quite a nice crate from Rust. So let's take a look at functools and see if there's a nice way to encode this without having to do it myself. I'm sure there's a lot more there. Docs.rs. So if you don't know Rust very well, every crate that has documentation in will define a docs.rs page. Unfortunately, that one seems pretty empty. Let's go back to crates. Yeah, functools is 0. I must be remembering the wrong phrase. It's iter tools, not functools. I gave the wrong name. Okay, Rust, iter tools. That's better. Okay. Okay, iter tools isn't giving me anything that's immediately obvious about what's going wrong. So I'm now wondering the best way to write this. Okay, I'm actually struggling to figure out how to write this properly. So I'm going to experiment with some stuff. It might take me some time to find something that works, and it might not be the best code, but I'll give it a go and see what I can come up with. Okay, so here's the logic I've been going for. There is a set of combinations that you can encode using binary because there's only two options. Now again, I'm not sure that this is the best way to do it. I think maybe I can just keep nesting for loops or doing some recursive function to define the operations, but this is what I'm trying to do. So the total combinations, I believe, is the total number of possible combinations is 2 to the 32. So if I had one possible number, it would actually be -1. So if I had one possible number, then the number of possibilities is 1. So I need the gaps between the numbers. So it'd be length -1. Okay, so if I had one argument 10, then there's 0 possible operations because I don't have anything to operate on. If I have two numbers, 10 and 19, then my operations will be add and multiply. So this is the length 2, -1 is 1, which means 2 to the 1 is 2, which is add and multiply. Now if we had 10, 19, 21, then our operations are add, multiply, multiply, add, multiply, mul. There you go. So that's 4 possible combinations. 3 minus 1 is 2. 2 squared is 4. So there's 4 possible total combinations. So that's what this total combinations is about. Now my operation set stores all of those, which I think is a bad way to do it. Generally, you want to generate them as you go and return them as you come up with them, so that you can return early if you want to. For this function, we only need to return if there's any possible combination found. So generating the full set of possibilities and then stopping on the first row is very, very inefficient. Anyway, at that point, we then keep incrementing a total count and then generating an operation set from it. So we need to convert the total, break it down as binary. So we kind of I'm really feeling like there's a better way to do this. So I'm going to sit and think about this a little bit more, see if I can come up with a better way. Okay, so I think it's actually it'd be possible to come up with a vector of all the possible combinations from doing the add and multiply using a recursive function. So I might try and encode that. So the function all combinations will take an iterator and it will return a vector of U32. I hope these data types are big enough, but we'll get to that. Now, my plan with this is we want to slice from 1 onwards. So we're going to do for op we'll do add combinations, this should be, equals calibration sets all combinations of vowels from 1 on. Actually, I can say if I need my base case for this recursive function. If the length of values is 0, then return an empty vector. Unless I need a 0 in it. I might need a 0 in it. No, because then if I multiply by it, it's always 0. So if val's.length is 1, then just return vals.toVec. Yeah, we're working with I32 instead of U32, so let's do that. Okay, so the add combination is all combinations of vals from the first index onwards. And we're going to map it. I think this is an iterator, iter.map, where we take the value and return x and vals 0. Let mul combinations is calibration set, except we are multiplying. And then our final vector is add combinations dot chain with mul combinations dot collect. Oh, need to spell that right. Okay, so we can borrow. All right. Temporary value dropped while borrowed. And we can turn it into iter to consume it. That's fine. I'm happy enough doing that. Let's format that. Okay, so now what this is doing is, imagine you have the vector of just 19. Just 19, okay? So it gets passed in. The values.length is 1, so it returns that. So what's returned is 19 goes to a vector containing 19. However, the full set is 1019. So what happens here is the values.length is not 1. So the combinations are, we find all combinations of just 19, which we now know as this vector, 19. And then we are adding this number to it. So 10 has the add combinations of 29. And then we chain it together, meaning one iterator followed by the other iterator. We chain it with the mul combinations, and the mul combinations is 10 times 19. That flattens, and you can see that if we add another number onto this, 16, 10, 19, then it will repeat that process. 16 add all the results from this version, chained with 16 times all the results from this version. So this should give us all possible combinations. So our combination possible now needs to check whether the key is contained within this vector. We could make this a hash set so that it avoids duplicates. I am banking on question 2, checking whether there's more than one solution. So I'm going to keep this vector in. Okay, so instead we will say calibration set all combinations of vals, which we will borrow, dot contains key. And we borrow this, presumably. Yes. And that's it. I'll go test that. It is not happy because of code that we're not using anymore. Okay, so I'm just going to comment this out. And it passed. Okay, let's take a more complicated test set. So let's say Only 3 can be made true. 3, 2, 6, 7. This has 4 combinations, so let's take this one. Test, function, test, harder, valid, line. I'm just going to... I could just run it on the real thing, by the way, but I like having a test set to check things with. Okay, so my values are 292. My vector contains 11, 6, 16, and 20. And I want there to be one result. And that is wrong. It does not work. It says it's not valid. Interesting. Why is that? I don't want to have to generate by hand all of these. So what I'm going to do is take a version with 3 arguments like this. I expect this to be 3267, and I expect this to be 81, 40, and 27, and I expect there to be one result. Let's try this one. And it's failed as well. Let's print line all combinations and see what it says there are. So I will do the calibration set all combinations of and brackets 81, 40, and 27. Let's see what it says. Failed, obviously. Okay, so it's giving me 4 results, which is clearly not right. So let's... I actually don't need to comment this out because it'll only give me print lines for failed tests, but I'm going to anyway. Use create calibration set. I'm just going to change this to use superstar. So I'm going to print line what vals is at every stage. Run that. Okay, we are, oddly enough, running into 27 multiple times. And we're only printing this, I think. Are we... Show me every time we print. Yeah, we're printing all the combinations. Let's just remove that for now. I only want vals being printed. 81, 40, 27, that's what we expect. 40, 27, that's what we expect. 27, that's right. But why do we then have another 27? Then we'd go through again, except that it might be easier to just save the combinations. So let's say sub combinations is and vals calibration set all combinations of and vals 1 down. Now we're going to print line this instead. Input vals, combo vals. And this will be subcombinations. Now I actually want subcombinations.iter. .map and subcombinations.iter.map. So that's going to put it on one line, and now we're going to run the test again. Okay, so the combo vowels is now 27. I should print this on one line. Input combo and I should so for the given slice input, return these results. So let's see what this says. Then return right. Yes. Okay, so if the values.len was 1, then we return just the vex. That's fine. We don't see the input 27 line. I mean, we could. We could put this in just so it's complete, and this will be vowels. Vowels. It'll be vowels. So let's do that. Input 27, right, is 27. Input 40, 27. Returned is 40 plus 27, right? And 40 times 27. Then the input of 81 will be added to these two values, there, and multiplied by these two values, there and there. But that doesn't contain $3,267. It does not. So what's the correct? In fact, this has two possible combinations. But we should be doing 40 times 27, right? So 40 times 27 is here, 1080. Correct. And then we are adding 81 to it. 1161. It's evaluated left to right. That's the problem. We've evaluated right to left. That's what the issue is. Okay, great. So that's what the test revealed. So we are evaluating everything right of the first value and then adding or multiplying by the left value, which means we've evaluated from the end to the start. We need to evaluate from the start to the end. So one possible way to do this, honestly, is to just, in combination possible, reverse it. iter.reverse. And I guess I can't directly pass that. So let's reversed is vals.iter.rev.collect, I guess. And then we'll pass that into here. Reversed. Doesn't know what to collect it to. Can I borrow? No. I think I need to force this to collect into a vector so that it has an unsized type at compile time. You're missing an explicit closure. Oh, so I can just do copied instead of map. That's nicer. That looks like it would do it to me. And I'm going to change the tests. Instead of checking that part A is 1, I'm simply going to check that combination is possible, where the combination is 3, 2, 6, 7, and the values are vec 81, 40, 27. We actually don't need any of this. And it's not equal, it's just assert. Assert the combination is possible. We expected and this should just be a slice. Okay. All right. Okay, that's okay. So that's what the problem was. I thought the logic was correct, but I was evaluating the wrong direction. So let's do a little bit of tidy up. We're going to get rid of all of this. Actually, I wanted the numbers from that. And down to here. And then harder line. And again, I want the numbers 292. And then I'll take these, paste them here. Test that. Nope. Test medium. Test short. Okay. One thing that I do want to check is that an invalid line doesn't do anything. So we're going to take this line with 4 combinations, which is going to be one of the harder ones to compute. We're just going to do function test invalid line. The result should be 21037. The input should be these. Okay, let's test this. Failed, because it said that it's invalid, but I was checking that it was valid. There we go. Now, let's strip out the stuff that is no longer needed. We don't need this print line. We don't need to save it to rets. We don't need this print line or this one. Great. So let's test test text. Test text. We are going to create our puzzle is include str ./puzzle/test.text. We are going to create a calibration set from it. Calibration set from str puzzle.unwrap. Then we're going to assert that the value of part A is the total calibration result, 3749. Now I'm actually expecting this to fail because I believe I'm returning the count, not the sum. That is correct. Actually, I can get rid of more stuff here. So let's part A, all combinations, I need those. Enum, that can go, and that's fine. Okay, so my part A implementation says count, I change it to sum, and then run the test again. And it doesn't like it because it can count, but it can't sum, apparently. We need to sum the keys. Dot keys? No. Dot map. So we'll take our key and a thing we don't care about, meaning underscore. Close the bracket, close the closure, and return key. And then we can't sum over I32s. Oh, we can, but it returns a usize. That's fine. I can convert that to a usize. Sum. Can I sum it as a usize? No. So I can sum it as an I32 and then convert it to a usize. Okay, that is giving me the right answer. So now I can finally get the puzzle input. Now in my main function, I can write input, and then I can write part A is calibs dot part A. Oh, we need to unwrap it. Unwrap part A. I cargo run this, builds, and unwraps on key missing. Really? I think it's because there's big numbers that don't fit in a U32. So my error message is wrong. It should be key missing or parse failed, really. But I could even do key parse failed. And then when I specify the error, I can do a key parse failed. Right, so because I'm storing everything as U32s, which is too small, I need to do it as I64s. So everywhere in here that is an I32 becomes an I64. And then we run it again. And we get an answer. Here is the answer. And it's the right answer. Hey! So it did take a long time. Let's see what part 2 is about. If it's simple enough, I'll go straight on with it. Otherwise, we may have to leave it for tomorrow, but I'll read through and take a look. Okay, it's actually not too difficult. I think I could do this fairly quickly. So it's saying that there's a new operator. It's not just add and multiply anymore, it's also concatenate. So the concatenation is you treat them as if they're strings, so 15 and 6 should concatenate together to make 156. So let's see, it's 100, yeah, 156 is there. So I think I can code this pretty fast based on how I've done it already. So I'm going to launch straight into it. So all combinations. This is now no longer true. This is all combinations no concat. And this is no concat, which should break a lot of things. This is now no concat. And we should feasibly be able to change this to combination possible with concat. Should be the same. No concat. And no concat needs to go in a lot of places, so I'll put it in the test names. Here and here. No concat. Invalid line, no concat. As test text, no concat. Looking mostly good. But we need to rename this. And we need to create a new combination possible with concat. This needs to be This needs to be all combinations with concat, and now I'm going to copy, this. I'm going to put this in with concat. Oh, I should write a test function for it so I know it's correct. With concat will be part B, where the correct solution is 11387. Okay. Part B, we don't have something for. I mean, I can write that very quickly so that I don't get warnings that things aren't being used. Which got rid of all of those. Excellent. So now we are just changing the all combinations with concat. So again, we have our vals.vec. We're now going to add another one, which is concat combinations, where we take the subcombinations, we iterate, and we map. For each number x, we take the x dot to string, that should be fine, plus vals 0 dot to string. This does put a bit of an issue because we're doing it right to left. So we're currently evaluating it left to right. Sorry, no, it needs to be like left to right. We're evaluating it right to left, but we reverse the vector. But it means that our combinations need to be, our concatenation needs to be flipped around. So if we're evaluating, it's one of these two. I can't figure it out off the top of my head, so I'm just going to parse and I'm going to filter map. Okay, why are you unhappy about this? We expected options, so if I just OK that, I can borrow the string. Parse needs to be to an I64. And that's okay. So now we are just going to .chain concat combinations. And with that, I should be able to cargo test, and it failed. So I'm going to change the way around this is, and it's now going to be vals 0 to string plus and x to string. Try that. Failed again. Okay, let's try and think more about this. So we are getting the result of 3749, which I am a little surprised by. Combination possible with concat, right? All combinations with concat. And then we are doing the concat combinations, yes. I wonder if I can print line the input and the concat. That'll be vals, and it will be concat combinations. Can I just print that iterator out? I can. Okay. So let's take a look. This test fails, so I don't want to look at it right now, but I will take my short valid line. I will change it to work with concat. It's still going to give me combination possible. So that's fine, but I'm also going to assert false to make the test fail so that I can see what it prints out. Combination possible with concat, and I have an iterator that contains only 10. Why does it only contain 10? It should contain Okay, the input is 19 and 10. I'm going to include the sub combinations here and test. Okay, so our input is 19 and 10. We do the sub on 10, and then we should be concatenating 19 with 10, but we haven't. That all looks like it should work, so I'm not really sure what's going on. X should be converted to a string. Let's do some print lines here. Print line val 0 and print line X. Why don't you like that? Statement found outside of a block. True, true. Let's add a block. Okay, so val 0 is 19, X is 10, so it should have given me I feel like my logic is fine, but my use of the language is not. Let's print out the combination. 1910, right. Let's parse it to I64. This will give me the results. But I'll need to debug, print it. Result is OK 1910. But I know that the filter map only contains 10. Doesn't contain 1910, which is what it should contain because I'm looking at it right here. By the way, does that work? No. So I can actually tell now from this printing out that it should be X and vals 0. It should be that way around. So I should be able to do that. And I should be able to take this inner part and put it here. Whoops, don't want a cargo run. I want a cargo test. Okay, so we're passing in our simple line, we're passing in 10 and 19. And then during the test, we are getting 10, 19 concatenated to 1019, which is right. That is the correct combination. The only thing that's missing now is why I'm getting an iterator over a vector of 10 instead of what I'm expecting. I wonder if this chain is not working as I expect, and printing it out like this isn't doing what I expect either. So what I'm instead going to do is collect it. And then I will chain it with the dot iter, which should be the same thing. It should behave the same anyway. Okay, concat combinations needs to be a vector of I64. And then we have an error, which is that I think we can consume this here, but useless conversion. Okay, so it's saying I can just plug it in directly. Okay, fair enough. Concat is 1019, so that's right. Did that fix it? It makes me a bit worried that this is wrong as well. So I am actually just going to collect on this and collect on this as well, just to keep it all the same. Then I just need to dot iter here. If I into iter, that consumes it and gives me an iterator over I64s instead. Okay, that should work now. And it failed because I'm asserting false, that's fine. If I take that line out and I run this test instead, and the test result failed. That's an awful lot to test on. Let's test against a line that would not be valid without. So we're going to test short valid line with concat. This is a better test case for what we're doing. 156 made up of 15 and 6. I'll go test. Valid. Another one. This one. So let's test a medium line with concat. Possible with concat. This will be 7290. And then the contents will be 6, 8, 6, and 15. And then we can test that. Oh, I needed to rename this with concat. That's a fail. Okay, why is that a fail? It panicked because it thinks it's not possible. Let's get rid of these print lines. I think they're muddying the waters a bit. No, it doesn't need to be a block either. Filter that. Okay, so for this, our input is 15686. Sub-result is between 3 combinations, which is 2 squared results, which is right. So our concat will be, wait, is it 15686 at the bottom? Ah, that's backwards. So we want 615 as a result. I think maybe what we should do is, instead of reversing, we should use 0 to the last thing. Let's do that instead. Okay, so instead of reversed, I'm not doing that. We're taking vowels. And then all combinations with concat, we will have current val is the last value. I can get last, good. I'm just going to unwrap it at this point because we've already checked. We've already checked that there is something in the array. So this unwrap is actually safe. Unwrap. Okay, so current val is that, and then we're going to compute up to how do we we'll do vals.length -2, I guess. Now every time I use val 0, it should instead be current val. And then otherwise that should be the same. Okay, so this is instead of reversing the vector and doing it in the normal order, which was a little bit of a hack, to be honest. I'm now deliberately computing it from left to right. And this fails for both of them, which is interesting. Let's narrow this down to just the valid line. So I'm just going to get rid of this test for now. Range start index 1 out of range for slice of length 0. So this unwrap that I said was definitely safe. Oh, I think it's because I do... yes. So vals.length. I think it should actually just be -1. Okay, that passed. How about the medium? Failed. The input is 68615, correct. The sub is something, I believe it. Then the result should be 620, 654, 684, and so this is taken 15 and put it on the end of everything. That's not exactly what I wanted. Okay, so I think it's basically it's the wrong way round, right? We're computing left to right, so we should be putting. No, we're right. That's the right logic. So for 686, we get a bunch of results. How does it think that you can do it? It's because you can concatenate 8 with 6, which means that I can't compute left to right. Which means I can't do the recursive function. So the concatenation is actually much harder than I realized. And not something that I'm going to be able to solve as I'm already over time. I thought I could code this quickly. It turned out to be more complex than I expected. So I'm going to return tomorrow. We won't be, well, hopefully we'll get to day 8, but we're going to start by trying to finish off the day 7 challenge. So thank you for watching. I'll see you tomorrow for hopefully the rest of day 7 and the start of day 8, but could also be an hour of banging my head against part 2 of day 7, whichever it happens to be. See you then. Okay, I couldn't let it rest until tomorrow. It was bugging me, so I decided to create another test to investigate things further. So what I've done is taken the inputs from test medium. I've created a new unit test, which will always fail, but it will print out all the in-betweens. And then I'm looking at the in-between, the intermediate results. And you can see that the input for 6 and 8, The sub-result, as in the all combinations of the array without the last value, is 6, which is correct. Concatenated together, that makes 68, which is right. So that gives us a final result of 14, 48, and 68. Now what I noticed is, when I then add the third value on, I'm expecting this to be what's in the sub. And if I run this test, what I instead get is 14 and 48. Essentially, it's taking off the last value, and I don't know why. So I am now trying to figure out why it's not bringing back the full array that it should be. So the sub combinations, we know at this point, this returns a vector of I64. This returns, this gives a value slice where it's going from 0 to values.length minus 1. So our values.length at this point is 3. So it should be giving 0 to 2, which means 0 and 1. So it should be giving the 2-length array. That is correct. And then at this point, the sub is saying that the sub combinations is empty, or rather doesn't contain all of the values that I would expect. So yeah, we're then concatenating the 6 onto the end of 14 and 48, but we should also have another value. So now I want to investigate why sub combinations doesn't contain all the values I'm expecting. And I wonder if it's simply not. Maybe what I can do is do a mute and then add combinations dot push or join. What does join do? No, join's not what I want. Can I push all of mol combinations on? Rust push vector to vector. Append. End. Is that allowed? We expected a mutable reference. That will also need to be mutable, and that will need to be mutable. So add combinations.append and mute concat combinations. Then we just return add combinations. Add combinations. Right. Now if I run this test again, sub is still too small. It's still not got everything. I'm not sure why it's not printing further in the backtrace. It's because my recursive function call was calling the wrong function. Now I'm actually getting all the print lines that I'm expecting. The assertion still fails, which is correct because I'm asserting false in my test. And that means that I can probably just do this, which I prefer to do. It means that I don't need everything to be mutable. It gives the compiler more of a chance to optimize as well. The cargo test failed because test foo isn't real. Now I uncomment this. Test passes. Test the full test file. Passes. Now I run it, and it is taking much, much longer to compute. So what I might do is just run it in release mode, just to speed it up a bit. Okay, I did get a result. It took quite a while. As I said in yesterday's video, it should be faster than that. There's probably a better way to do it. Now, one way that I could probably make this faster is to return all the intermediate stages instead of defining a full vector at every stage. I could try generating the results and comparing them against the index as I go, and then stopping if the result is already too large. I mean, when I generate all the combinations, if the number is already too big, then I might as well get rid of it. It's not going to get any smaller. Add, multiply, and concat will only make numbers larger. So I could even add a filter in to my all combinations to filter out values that are too big already. That will probably save a bit of compute. Before I do anything else though, I will just check that this is the right result, because I am assuming a lot, and it is the right answer. Now, I guess I'm in the mood, so I am going to try and add a filter in. So my max val will be an I64. Let's see how this breaks everything. I want a max val here. I want my max val of key, and max val is never used. Correct. What I want to do is I wanted this on the with concat operation, so I'm just going to backtrack on that. Okay, with concat we'll have max val of I64. The max val here will be also I64. Max val here will be the key. And now it's unused. So what I want to do is at this point, I'm going to filter any value that is less than the max value, or equal. Should probably use or equal, or I will be filtering out the correct results. Okay, it doesn't like it because X is a reference, so I can dereference that in the tuple. That should work. Let's run the test to make sure it's okay. It is. Cargo run in release mode. And that's much, much faster. It still takes a second to compute, but that's fine. So with that filter and with that correct answer, the reason that I got stuck and gave up is because my second version of the recursive function call was calling the original recursive function. So the implementation broke down. I should have realized when my print lines were only printing one time, because it should have recursively got deeper into the array and still printed those values out. But I did work it out in the end. I took much longer than my hour window, but I did want to get the puzzle finished. In future, I will continue doing the same thing. I'll determine if I'm close to finishing, and if I am close to finishing, I'll continue. If I'm not close to finishing, I'll cut it off and go to the next day. I would rather keep days to a single video if I can, but only if I can. The days are only going to get more complex as we go through Advent of Code. So with that, thank you again for watching, this time for real, and I'll see you in tomorrow's video.